prepare the concentrated stock iron standard solution, begin by dissolving the iron wire in 30 milliliters of dilute or 6 molar hydrochloric acid. Gently heat this mixture on a hot plate until all of the iron wire is completely dissolved in solution. Iron being magnetic, you can utilize the magnetic stir. Turning the stirrer on, and the iron wired pieces will mix or stir in the solution. As the wire dissolves, the solution will take on a yellow colored appearance, and you want to ensure that there's absolutely no traces of iron wire whatsoever. This may take a few minutes. Make sure that the solution does not run dry. You can add a few milliliters of dilute hydrochloric acid, additional amounts if the solution begins to go dry. Notice the solution here as the more and more iron wire dissolves, taking on more yellow color. That's due to the iron 3 ion. Completely dissolved. Make sure that you pay close attention to the solution and that you haven't overlooked any little fine traces of wire that may remain. This solution is a deep yellow color and totally free of wire particulates. The next step in the preparation of the iron concentrated stock standard is to now reduce the iron that's currently in the +3 state into the +2 state. That's done with the aid of a reducing agent, hydroxylamine hydrochloride. We're going to start by first increasing the volume of the solution by adding 20 to 25 milliliters of deionized water. This will give an environment for the hydroxylamine hydrochloride agent to dissolve in. You want to swirl until all of that is dissolved in the solution. And in order for the iron to convert from the +3 to the +2 state, we have to increase the hydroxide ion concentration. We want to get the pH somewhere between 1.5 and 3.5 for this reduction to take place. So I'm going to add dilute ammonium hydroxide, which is 6 molar ammonia, to this solution until I observe the iron 3, which is a yellow color, becoming the colorless or pale greenish iron 2 form. So using a Pasteur pipette, I want to carefully add the ammonia. If you add too much ammonia, the pH will become too basic and you'll begin to precipitate out iron hydroxides. You don't want that. So I can initially add full pipettefuls at a time of the ammonia, and when I notice that there is a lightening in the yellow color, then I'm going to slow down my delivery of the ammonia. Okay, keep in mind that we're having to neutralize the bulk of that 30 milliliters of 6 molar HCl that was initially added. So this may take quite a bit of ammonia, but you don't want to add too much at the wrong time. Okay, so it's gotten a little bit lighter here, so I'm not going to squirt anymore. Just kind of like you're doing a titration. Drop-wise add the ammonia. And when it turns into iron 2, it'll be a rapid loss of color, of the yellow color. Right there, it almost looks like it's colorless. Add a couple more drops. this point, we're going to check the pH and make sure that the pH is in range for that complete reduction to take. After the solution is changed to the colorless state, you want to use a calibrated pH meter to confirm that the pH is between 1.5 and 3.5. So I can see here, do not test the pH though until the solution has made a color change. In the yellow form, the solution is still very acidic and you will ruin the electrode. So at this point, in checking this mixture, I wasn't quite high enough yet because the pH was less than 1. So I've now added a few more drops of the 6 molar ammonia until the pH has increased now in that range. So I'm right around a pH of 3. At this point, it's very vital that you rinse all of the electrode washings from the electrode very, very thoroughly back into the beaker. We're having to dilute these iron solutions down to the 10 to the negative 5th molar level, and any loss of iron along the way will translate into a lot of error. So do an extra good job at rinsing those electrode washings back into your beaker. Complete the preparation of the concentrated stock iron standard by quantitatively transferring the iron 2 solution from the beaker into your 1 liter volumetric flask. You want to make sure that you rinse the beaker, transfer those rinsings through multiple times. Rinse, 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 rinse. After rinsing the beaker thoroughly and transferring those rinsings to your 1 liter volumetric flask, you want to proceed to dilute this solution to a final volume of 1 liter. Okay, until the water or solution meniscus is exactly on the line, and then cap your volumetric flask appropriately. In this case, this requires a ground glass stopper, and then mix by inversion 3 or 4 times.